Hi friends, now we are going to discuss about the second problem on heat exchanger. In this question, a counterflow heat exchanger is used to cool the engine oil. In this question, the specific heat capacity of the engine oil is given. But in some other questions, suppose if any other fluid other than engine oil, suppose if the specific heat is not given, we must go through our HMT data book. In this HMT data book from the page number 25, we can able to see a lot of liquids, property values for the liquids in saturated state is given. Here ethylene glycol is there, the engine oil, for our question the engine oil is given. Here the specific heat capacity is 1796228483 from the variety range of the temperatures from 0 to 160 degrees Celsius. Similarly, a lot of property values are given for the transformer oil or for the mobile therm, then for the butyl alcohol and for the molten salt. Okay, a lot of property values are given, hence we need to take all these values from the data book too. But in our question, the specific heat capacity is given from 160 degree to 60 degree. That means the hot fluid, the inlet temperature is 160 degrees Celsius and the outlet temperature of the hot fluid is 60 degrees Celsius. It is cooling with another liquid, that means H2O, which is available at 25 degrees Celsius as the cooling medium. Here, the mass flow rate of the H2O having the inner diameter tube is 0.5 meter. That means we have the shell and tube heat exchanger. Through the tube, the water is going on, is flowing through that tube. Here, the diameter of the tube, inner diameter of the tube is 0.5, and the mass flow rate is 0.2 kilogram per second. That means in a second, 2 kilograms of mass fluid is flows. While flow rate of the oil through the outer diameter is 0.7 meter. That means the hot oil is circulated under the surface of the tube. That means having the diameter, outer diameter 0.7 meter. It has also the mass flow rate of 2 kilograms per second. Here the overall heat capacity is given in the question. Suppose if it is not given, the same also taken from our HMT data book. You can able to see in the page number 120, the page number 156. Okay, in 156, different overall heat transfer coefficient value is given. The range of value overall heat transfer value is given here to the water to oil, water to lubricating oil, water to engine oil. This also given. Water to oil, water to lubricating oil. Okay, water to lubricate oil. It is better to use the water to gas oil or water to lubricating oil. It is ranges from the 100 to 350. You can able to take it as in the average of 100 and 350. That means 225. For 100 plus 350 divided by 2, that means 425. That means actually 450, 225. It's better to take the average value of the overall heat transfer coefficient. It is a range of values are given. Now, our question is to solve or to find out how long must the heat exchanger be. Now we are going to discuss all about the single pass heat exchanger. Single pass heat exchanger means here the tube is not folded. Here the tube is a straight line. Now I am drawing a diagram of a single pass heat exchanger. Okay, this is a tube having the inlet diameter 0.5 meter. And it is surrounded by another shell. Through with the shell, the engine oil is flows on. Here it is a counterflow heat exchanger. This is a counterflow heat exchanger. Hence we need to indicate the direction of the oil flowing of the oil to. This is a TH, inlet temperature TH. Okay, through this hot temperature outlet. This is counterflow heat exchanger, hence the water is flowing in the opposite direction. This is capital TC and this is small tc, this is small th. Now we are going for the given data. Taking the given data. Here you can see mass of the hot fluid. M dot of hot fluid is mass of hot fluid is the 2 kilogram per second. 2 kilogram per second, and the specific heat of the hot fluid is 2130. If it is given in the question, it is good, or otherwise we need to take it from the data book. And capital TH, the inlet temperature of the hot fluid is 160 degrees Celsius, and capital TC, outlet temperature of the hot fluid is 60 degrees Celsius. Here the next one is the cold fluid, that m dot C is also the 2 kilogram per second, and the Cc is, already we know the specific heat capacity of the water is 4180 joule per kilogram Kelvin. As I already said, we can able to take it from the data book already, or we need to mug up that particular value. Then outlet, the inlet temperature of the TC of the hot cold fluid is 25. It is also already given in our question. Now we need to draw a plot for temperature plot for this counterflow heat exchanger. Okay, temperature plot for counterflow heat exchanger. Here you can see for the hot fluid temperature somewhere else here. If the length goes on increasing, the temperature goes on decreases due to the heat exchanging process. That means here somewhere we will get the 60 degrees Celsius, here 160 degrees Celsius. This is capital TH, this is capital TC. Okay. Similarly, this is the inlet side of the water. Here somewhere here the water will enter inside the tube, and it flows in opposite direction. Opposite direction means here, opposite direction. Here the hot fluid flows in this direction from left to right, here the right to left, because it is counterflow heat exchanger. Here inlet temperature of the cold fluid is 25 degrees Celsius. Now we know we need to find out this outlet temperature of this hot cold fluid. For that purpose we need to equate the heat transfer equation, the energy conservation equation. That means, as we know, the heat transferred by the heat gained by the cold water should be equal to the heat lost by the hot water. This is the heat loss. This Q amount of heat will be equal to the gained amount of heat in the cold fluid. Here Q is equal to m dot H into Ch, capital TH minus capital TC will be equal to m dot C into Cc, small cc, of small th minus capital small tc. Here we don't know the value of the th. Our task is to find out this small th. Okay, already we know this m dot h is equal to 2 kilogram per second, and the specific heat capacity of the hot water is 2130, and the capital th is 160 degree minus capital TC is 60 degree, equal to, here also MC is equal to 2 kilogram per second into water. This is specific heat capacity of water 4180 into capital TH, we don't know. This small TC is equal to 25 degree Celsius. From this equation you can able to find it out. That means 2130 into 100 divided by 4180. Okay, 4180 plus 25. That means outlet temperature of the hot water is cold water. Outlet temperature of the cold water is 75.95 degrees Celsius. This is 75.95 degree Celsius. Now our question is to find out what must be the length of the heat exchanger. That means what must be the length of the heat exchanger. Length means to find out the area of the heat exchanger. From this area we can able to find out the length of the tube. Actually the heat through this tube, the heat transfer is taken place in the surface area of the tube. Okay, it is only the heat transfer taken place in the radial direction. Okay, that means towards the length. The length goes on increasing, the area also increasing. Hence, surface area of the tube is equal to pi dl. Okay, inner diameter, we have to take it as inner diameter, pi into d into l. This is the surface area. It is very important here. Always the heat transfer takes place in the surface area. We must consider about the surface area. Okay. Now, as per the equation, Q is equal to overall heat transfer into effective area into delta T min for counterflow heat exchanger. It is very important. Here we need to take the delta T min for counterflow heat exchanger. From the data book, you can able to take the formula in the page number 152. Okay, 152. Here counterflow heat LMTD for the counterflow heat exchanger is given. As we know, this is the T1, this is the delta T1, and this is delta T2. Delta T2. Here from LMTD, TD for counterflow heat exchanger, it is delta T1 minus delta T2 divided by ln delta T1 by delta T2. Here delta T1 means this temperature difference, that means 160 minus 75. Delta T1 is 160 minus 75.95. Here you will get the answer around the 84 degrees Celsius. 160 minus 75.95, around 84.05. Here T2, delta T2 is around 35 degrees Celsius. Hence we substitute all these values in this equation. You will get 84.05 minus 35 divided by ln 84.05 divided by 35 minus 35 divided by ln 84.05 divided by 35. Here you will get the LMTD value for counterflow heat exchanger is this 55.9 degree Celsius. Okay, here it is 55.9 degree Celsius. Now we have to go for calculating the area of the heat exchanger. For that purpose, we need to find out the Q. What is the amount of heat transfer Q? As we know from this equation, from this enthalpy equation, we have to find out this Q from any one of this formula. Here Q is equal to m dot h into Ch into Th minus Tc. That means 2 into 2130 into 100. How much? That means 42,000. Sorry, yes, 426,000 watt will be equal to, and the U is also given. This is 250 into surface area into delta T, that means 55.9 degrees Celsius. 42 divided by 250 into 55.9. You will get the surface area as 30.4830 meter square. From the surface area, we can able to find out the length of this tube. Okay, here the diameter, inner diameter is also given as a 0.5 meter. This 0.7 is also given. It is obsolete data. This is outer diameter of the pipe. It is not very important. It is actually obsolete data. Here only we need to consider about the inside diameter of the pipe. Hence, surface area is equal to pi into d inner into length of the heat exchanger, equal to pi into 0.5 into L equal to 30.483. From here, the length of the heat exchanger equal to 19.37 meter. The length of the tube should be 19.37 meter will be there for the heat exchanger. Then only we will get this desired temperature, inlet and outlet temperature. Hence, it is very important to find out how much the length of the heat installed to the designed heat exchanger must be. To find out that purpose, we are using all these calculations. That's all. Thank you for this second problem. This is a